we're going to go on to geometric sequences, which is almost exactly like arithmetic sequences in some ways. The formulas are different. It's jumping up quicker because instead of adding a number, this time what are you doing? Multiplying. So let's use the sequence 5. Hold on. Alright, so 5, comma, 10. What would come next?
20.
20. Alright, what's next?
40.
Alright, so in this sequence, what's my value for U1?
5.
U1 is the first term still, and U1 is 5. What's my value for R?
2.
2. Why? What does that mean?
It's the difference. Common difference.
It's kind of like the common difference, but in this case, it's called the common ratio for R. Right. So it's the number you're multiplying by to get the next number each time. So it's times 2 times 2 times 2. In this particular case, it's not that hard to figure out that R is 2. But let's say I gave you one that was slightly harder. Let's say I had a sequence that started off with... I didn't ask it, but yes. All right. Let's say our number starts with 40, or a sequence starts with 40. Then it goes on to negative 10.
Oh, and then it goes to like positive 20. Positive 5. That was so how do you do that?
What does it go on to next? Do you know?
Yeah, it's 2.5.
2.5. How did you? Oh, that's okay. Well, not really, because you can't see. All right, cool. We can see again. So you said it was 2.5?
Yeah.
All right. So yes, you are right when you're saying you're dividing by negative 4, but that's not our R. But do you know how to figure out our R?
You do negative 10 divided by 4.
Exactly. R will always, if you divide the second term, U2, by U1, you can figure out what the R is. So in this case, it's negative 10 over 40. And what does that give you?
4. Negative 4.
No. Careful.
Negative 10 divided by... negative 2.5.
Negative... Tell me again.
Sorry.
Negative
0.25.
Negative 0.25. Exactly. All right. So we have negative 0.25. That is our R in this particular case. Okay. So if you need to figure out any term, the 5th term, the 100th term, whatever term, you do something very similar to what you do to arithmetic sequences. You just plug it into this formula. UN equals U1 R to the n minus 1. We're not going to go over that. It's just pretty much plugging directly into a formula. Sorry about that. But what we will talk about briefly is if I give you 2 random terms. So let's say I told you that U3 is a number. We're not going to actually do a whole one. We're just going to talk about it. And then I told you that U8 is equal to another number. And I asked you to find U1 and R.
Is it something like 8 minus 3, something like that? But having like backflashes with it.
Well, what did we do? We plugged into the formula for arithmetic. We're going to do the same. We would set up 2 equations. So we would set up an equation for that 2 times, just the same way we did for arithmetic sequences. And when we have our 2 equations, since it's geometric this time, what will we do to the 2 equations?
You multiply them. No, divide.
Divide them this time instead of subtracting them. And that's it. That's the main difference.